Hey everyone, I hope you're doing well. It's Mr. Irwin. We're going to move on in the world of algebra. Previous lessons we were studying equations. Today we're going to start discussing inequalities. And an inequality, any mathematical statement that compares two values that are not equal. Now, in previous lessons we talked equations where both sides of that equation meant or stood for the exact same value. With inequalities, those two values will be different, and we'll use an inequality symbol, either less than or greater than, to determine whether one side of the equation has a greater or a lesser value than the other side. What is similar with equations is inequalities can have solutions, and just like equations, solutions to inequalities are any value that we can substitute into the variable of the inequality to make that inequality true. Now, before we start solving inequalities and identifying solutions, I want to go over all of the inequality symbols with you. Some of them may be familiar to you, some of them may be brand new. Let's start with this one. It's a little arrow pointing to the left, and if you remember from previously in this school year, that means less than. But now we are going to get algebraic with it. So an inequality featuring a less than symbol could look like this. Y is less than 5. Because y is a variable representing an unknown number, solutions to this inequality would be any number that would make this inequality true, any number that is less than 5. Can you think of any numbers that I could substitute into y that would make this true? Any numbers that are less than 5. And hopefully you're identifying there are multiple solutions to these inequalities. I could plug a 4 in here. 4 is less than 5, or 3, or 2, or 1, or 0. I could even go into the negative realm. -1 is less than 5. -8 is less than 5. Even decimal or fractions could fit in here. 2 1/2 is less than 5. -1.7 is less than 5. There are an infinite number of solutions to an inequality like this, and any value that I can substitute into y to make this true would be considered a solution. Let's talk about the other symbol I think you've seen before. An arrow pointing to the right. This is greater than, and algebraically I could have an inequality like this. T is greater than -2. Well, to make this inequality true, any solution would be a value that I could substitute into t that would be greater than -2. Is 0 greater than -2? Yes, so 0 is a solution to this inequality. 1, 2, 3, all the way to positive infinity, all of those values are greater than -2. What about something like -4? Is -4 greater than -2? Well, -4 is further left on the number line. It is not greater than -2, so -4 is not a solution to this inequality. What about -2? If I put -2 in for t, is -2 greater than -2? It is not. So -2, even though it is listed in this inequality, -2 is not a solution to the inequality. Now, two new inequality symbols I don't think you've seen before. We have a less than symbol with a line underneath it. This means less than or equal to. So now in our inequality, if I had m is less than or equal to 10, any value that's less than 10 would make this true. And now any value that is equal to 10 would also make this true. So solutions to this could be 9, 8, 7, 6, all the way down. All those values are less than 10. But now I could plug a 10 in here as well because 10 is equal to 10. So solutions to this inequality are values that are 10 or less. Final inequality symbol, we're going to flip that around. A greater than symbol with an equal to sign means greater than or equal to. Works the same way as the previous symbol. Our example is x is greater than or equal to 7. Any value you could plug into x that is greater than or equal to 7 would make this true. That includes 8, 9, 10, 10 and a half, 15, 2,143. Those are all greater than 7, but also included in that solution set is 7 itself because 7 is equal to 7. All right, let's practice writing some inequalities. So here's our first example. An airline company allows each passenger's luggage to have a maximum weight of 50 pounds. Write an inequality to represent the maximum weight of a passenger's luggage. So just like when we were writing equations, our first step is to identify a variable here. What don't we know? And in this situation, we don't know how much a passenger's luggage would be. So let L equal the luggage weight. And now what are we comparing that luggage weight to? We know the airline company is looking for a weight of 50 pounds. So I'm comparing my luggage weight to 50 pounds. Now, in order for a passenger to board the airplane, how does their luggage weight need to compare to 50? Well, 50 is the maximum. So their luggage weight needs to be less than 50. One last thing to check, could their luggage weight be exactly 50? An airline company allows each passenger's luggage to have a maximum weight of 50 pounds. So 50 is acceptable. 50 is a solution here. So this could also be equal to. So the inequality representing a passenger's luggage needing to be or have a maximum weight of 50 pounds would be L is less than or equal to 50. So a couple questions here. Can a passenger with a bag weighing 48 pounds board this flight? Well, is 48 less than or equal to 50? Yes, it is. It is a solution to this situation. Next question. What if their bag weighed 55 pounds? If you plug the 55 into L, is 55 less than or equal to 50? No, it is not. So 55 is not a solution. A passenger with a bag weighing 55 pounds would not be able to board the flight. Finally, what if it is at exactly 50 pounds? Plugging 50 into here, is 50 less than or equal to 50? Well, 50 is equal to 50, so it is true. Yes, it is a solution. All right, next scenario. To be classified as a hurricane, a tropical storm must have a sustained wind speed faster than 74 miles per hour. Let's write an inequality to represent this scenario. First, identify your variable. What don't we know? Well, the unknown here is the wind speed of a hurricane. So let W equal wind speed. We're going to take that W and I'm going to compare it to the benchmark for a hurricane, which is 74 miles per hour. Now, in order for a tropical storm to be a hurricane, it must be faster than 74 miles per hour. So how does the storm's wind speed need to compare to 74 in order to be a hurricane? It must be faster than, it must be greater than 74. Could it be exactly 74 miles per hour? And looking at our problem, no, it needs to be faster than that. So we are not including an equal sign here. W, the wind speed, needs to be greater than 74 in order for it to be considered a hurricane. Is a tropical storm with 112 mile per hour winds considered a hurricane? If I take that 112 and I plug it into W, is 112 greater than 74? Yes, it is. So if a storm or a tropical storm had wind speeds of 112 miles per hour, it would be considered a hurricane. What about 72 miles per hour? Is 72 greater than 74? No, it is not. No, it would not be a hurricane. No, it is not a solution to this inequality. Finally, 74 miles per hour. Is 74 greater than 74? No, it is not. 74 is not a solution. All right, one other way to solve inequalities this year, just like we did with equations, is to use substitution. I can give you a set of possible solutions, and it will be your task to substitute these values into the variable to see which ones make the inequalities true. Now, with inequalities, as we saw a couple slides previously, there can be multiple solutions to an inequality. So do not stop once you find a true solution. Make sure you test all of the values in the set. Let's take a look at the first one. P is less than or equal to 18. My first value is 14. If I plug the 14 into P, is 14 less than or equal to 18? Well, 14 is less than 18, so 14 is a solution. 16, plugging it into P, is 16 less than or equal to 18? 16 is less than 18, so 16 is also true. 18 plugged in here, is 18 less than or equal to 18? Well, 18 is not less than 18, but it is equal to, so it is a solution as well. 20 plugged into P, is 20 less than or equal to 18? No, 20 is greater than 18. It is not equal to, so 20, not a solution. So based on the set of numbers you were given, only 14, 16, and 18 are solutions. Let's try one more. X is less than 57. If I take my first value in the solution set, 43, and plug it into X, is 43 less than 57? Yes, it is. Is 51 less than 57? Yes, it is. It is a solution. Is 57 less than 57? No, 57 is exactly 57. It is not less than, so it is not a solution. And then finally, 62, definitely not less than 57. The only solutions in this set are 43 and 51. All right, on your screen, I have 3 inequalities along with 3 different solution sets I want you to test out. Go ahead, copy them down on a sheet of paper, pause the video, work them on your own. When you're done, start playing the video again to check to see how you did. All right, hopefully you gave yourself enough time to complete all 3 of these. Let's check your work. M is greater than or equal to 16. 11 is not greater than or equal to 16. 14 is not greater than or equal to 16. 16 is equal to 16, and 19 is greater than 16. So solutions here are 16 and 19. Over here, J greater than negative 13. If I plug negative 16 in here, is negative 16 greater than negative 13? It is not, because it is further left on the number line. Negative 13, is it greater than negative 13? No, it is equal to. Negative 4 is further to the right on the number line than negative 13, so negative 4 is greater than negative 13, and a positive 2, any positive value would be greater than a negative value, so it is true. Negative 4 and 2 are solutions here. Down below, G is less than or equal to 1/2. 1/3 is less than 1/2. 4/10 is less than 1/2. 0.5 is equal to 1/2, and 7/8 is greater than, so it is not true. 1/3, 4/10, and 5/10, all solutions to that inequality. Make sure you complete the independent practice assignment for this topic, take a picture of your work, and upload your file for submission. I'll see you guys next time.